Hello everyone and welcome back to our notes for Chapter 2 of Algebra 1. So in these notes our goal is to learn about a new notation. Now a notation is simply another word for the way we write things. So what we're learning right now is not something new math-wise, it's just a new way to write the same things that we've been doing. Our old way of writing things is to say something like this when we write an equation of a line. Y equals 2x plus 7. The new way that we're going to write things today is f of x equals 2x plus 7. Now, there are a couple things I want you to notice. Instead of writing a y, we used this notation. This notation is another way of writing y. In this notation, the f is the name of the function, and the x is the input of the function. When we say this out loud, we don't say f parentheses x, we say f of x when we read that out loud. Now, if you think about equations as being like machines, you plug something into the machine and it tells you the answer, the output. This symbolizes the output, and this part of the equation over here is what we call the function. This is the machine, or what we're doing to our inputs to calculate our outputs. You'll notice that this side of the equals sign looks exactly like this side of the equal sign. The only thing that's changing is that we're writing the y a different way. We're writing it as f of x. So let's talk a little bit about why we might want to do this and how we can use this type of notation to be more specific about what we're saying in math and more precise. Function notation is just a different way of writing an equation. It allows us to see both the x value and the y value for a function at the same time. At the end of the problem, when we're using function notation, your answer is going to look like this. F of 2, I'm just going to choose, and this is just an example. This is an example type of answer. F of 2 equals 7, or let's use negative 7. When your answer looks like this, what we can see is that our input, or x value for this function, was 2, and our output, or y value for this function, was negative 7. The x is always the number that's inside of this parentheses, and the output is always the number on the right-hand side of the equal sign. We can still do everything that we're used to doing when we're using function notation. We can still plug in x values, and we can still solve equations even when we're writing our work in a slightly different way. So let's take a look at some examples. This is an example of what we've been used to doing, or what we did before, earlier in this chapter or in other chapters. If I had said, suppose y equals 3x minus 8, and it said find y when x is negative 3, then what we've always done is take that value and plug it into the equation instead of the x. So we've always had y equals 3, and then replace the x with negative 3, and then minus 8. Now, when you simplify this, 3 times negative 3 is negative 9, and negative 9 minus 8 would give me negative 17. Our final answer here would just be y equals negative 17. Here's what we're going to do now to be more specific about our notation. If f of x equals 3x minus 8, find f of negative 3. Now remember, the number inside the parentheses is always your x value. So just like we replaced this x with our number, we're going to replace all of the x's that we find in this equation with the negative 3. So we would write this, f parentheses negative 3, so f of negative 3 equals 3, and then I'm going to replace the x with negative 3, minus 8. Now, just like over here, we're going to start by simplifying 3 times negative 3, which is negative 9 minus 8. And then we're going to have negative 17 as our final answer. But it's not going to just say y equals anymore. Instead, we're just going to drop this down and we're going to say f of negative 3 equals negative 17. Now, the advantage of writing our answer that way is that in this way of writing our answer, we know the y value is negative 17 if all we have is the answer, but we don't know the original x value that we plugged in if we just look at this answer. However, if we look at this answer, we can tell that the original x value that we plugged in was negative 3 and the y value was negative 17. So we have more information here. Here we can see the original input. There we go, input was negative 3. Whereas in this notation, if all I have is my final answer, I can't tell what that original input would have been. Now, in a similar way, we can do the same thing with y. So suppose that you know that your y value is equal to 3x minus 8. Find the x when the y value is 10. This time we would take this 10 and replace the y. So we would have 10 equals 3x minus 8. Now, in order to solve this, in order to find x, we would need to use our process of solving equations. So I would add the 8 on both sides. I would have 18 equals 3x. And then I would divide by 3 on both sides, and I would get x equals 6. And if I look at my final answer here, I can tell that the x value that I would need in order to get a y value of 10 would be 6. And that would be my final answer. Now, if we look at what we're going to do now, it's very similar. Instead of y, we have f of x equals 3x minus 8. It still says find the value of x so that f of x equals 10. If f of x equals 10, then we're going to replace the entire f of x with a 10. So we would have 10 equals 3x minus 8. Now, just like before, we're going to need to rearrange this using our solving equations process. So I would add 8 on both sides. I would get 18 equals 3x, and I would divide by 3 on both sides. So I would get 6 equals x. But when I write my final answer here, it's going to look a little different. I know now that my x value is 6. So what I'm going to do is take that 6 and write it inside of this parentheses. So I would have f of 6 instead of x equals 10. What that allows me to do is to once again see the input and the output at the same time. Whereas in this final answer, I can only see the x, the input. Now I can see both the x and the y. Let's take a look at a couple more examples. So, If I say, suppose f of x is equal to 3x minus 15, and I say use that equation to calculate the following. The first question is find f of negative 3. Whenever a number is inside of the parentheses, that is a value of x. And I can remember that because the x is inside of this parentheses. So what I'm going to do is find all of the x's in this equation and replace them with negative 3's. So I would have f of negative 3 equals 3 times, and instead of x, I would write negative 3 minus 15. Now, 3 times negative 3 is negative 9, and negative 9 minus 15 is negative 24. So my final answer would be f of negative 3 equals negative 24. In other words, when my input, which is inside the parentheses, is negative 3, my output is negative 24. I could also give you a question like number 3. Find the value of x such that f of x equals 30. You'll notice that this time the number that I've given you is not inside the parentheses anymore. It's f of x. So I'm going to go back to my equation and replace the entire f of x with a 30. So I'm going to have 30 equals 3x minus 15. Now to solve this, I'm going to need the same process as solving equations. So I would add 15 on both sides, and I would get 45 equals 3x. Then I would divide by 3 on both sides, and I would get 15 equals x. To show in my final answer both the input and the output, I would take this x and replace the x here. So I would have f of 15 equals 30, which was already here. And that would be my final answer. All right, we will do number 2 and 4 in class when I see you again. Thank you guys so much for watching. Have a great day.